When most people think about Linux distributions, they imagine something familiar. You install the system, you use a package manager. Configuration files live in different directories across the file system, and over time your system slowly becomes unique. Maybe slightly messy, maybe perfectly tuned, but definitely shaped by months or years of changes. Now imagine a Linux distribution that challenges that entire model. A distribution where your entire operating system can be defined in a single configuration file. A distribution where you can roll back your system like a version-controlled project. A distribution where reproducibility isn't a buzzword but a core design principle. That distribution is NixOS. In 2026, it might be the most powerful Linux distro available. But power doesn't automatically mean practicality. And innovation doesn't automatically mean usability. So in this deep dive, we're going to explore what makes NixOS fundamentally different, how its declarative model works, what the so-called immutable architecture really means, and whether this system is something you should actually consider running on your daily machine. To understand NixOS, we first need to understand the problem it's trying to solve. Traditional Linux distributions like Ubuntu, Fedora, or Arch Linux follow an imperative model of system management. You install packages one by one. You edit configuration files manually. You enable services individually. Over time, your system evolves through commands and manual changes. If you forget what you did 6 months ago, good luck reconstructing it exactly. If an update breaks something, rolling back isn't always straightforward. NixOS approaches this differently. At the heart of NixOS is the Nix package manager, which is also available independently on other Linux systems and even macOS. But on NixOS, it's not just a package manager. It's the foundation of the entire operating system. Instead of installing software imperatively, you define your entire system declaratively. That means you describe the desired state of your system in a configuration file, usually configuration.nix. In that file, you specify which packages you want installed, which services should run, which users exist, what desktop environment to use, even low-level system settings. Then you run a rebuild command. And NixOS constructs the system to match that description. Think about that for a second. Your operating system becomes code, not just scripts or tweaks. The entire system configuration is treated as a reproducible definition. This is where reproducibility becomes more than marketing language. If you copy your configuration file to another machine running NixOS and rebuild, you can recreate almost the exact same environment. Same packages, same services, same behavior. It's like having infrastructure as code for your personal computer. In 2026, when developers increasingly rely on containers, cloud infrastructure, and reproducible environments, this philosophy feels incredibly modern. It aligns with DevOps practices. It aligns with version control workflows. You can store your NixOS configuration in Git. You can track changes. You can roll back not just software updates, but entire system states. And that brings us to one of NixOS's most powerful features: atomic upgrades and rollbacks. On most Linux distributions, when you update your system, packages are replaced in place. If something goes wrong, you may need to manually downgrade or fix conflicts. On NixOS, each system configuration is built as a separate generation. When you rebuild your system, it doesn't overwrite the old one, it creates a new generation alongside it. Your bootloader keeps entries for previous generations. If a new update breaks your system, you can reboot into an earlier generation with a few keystrokes. This dramatically reduces the fear associated with updates. You can experiment more freely. You can upgrade aggressively, knowing you have a safety net. Under the hood, this works because of how Nix stores packages. Instead of installing software into standard directories like user, bin or per lib in a mutable way, Nix stores packages in the Nix store, typically under Nix store, with unique cryptographic hashes in their paths. Each package is isolated. Different versions can coexist without conflict because their paths are distinct. This approach eliminates many traditional dependency issues. In other distributions, installing one version of a library can break another application expecting a different version. In NixOS, multiple versions can exist side by side. That sounds almost magical, and in many ways, it is. But let's address the word immutable. People often describe NixOS as immutable. That's not entirely accurate in the same sense as some container-based systems. The file system isn't completely locked down, you can still make changes. But the system configuration is declarative and reproducible. The core idea is that your system state is defined, not accumulated chaotically over time. In practice, this means fewer snowflake systems. In traditional setups, each machine becomes a unique snowflake, shaped by manual tweaks. In NixOS, machines can be cattle instead of pets. You can rebuild them from configuration. You can manage fleets of machines with shared definitions. For developers and system administrators, this is extremely attractive. It reduces configuration drift, it improves consistency. It makes debugging easier because you know the exact declared state. But what about everyday desktop users? Is this overkill? Here's where things get interesting. In 2026, NixOS has matured significantly. Hardware support is broader, the community is larger. Desktop environments like GNOME and KDE Plasma run smoothly. Gaming through Steam works with additional configuration. Many mainstream applications are available through the Nix package repositories. However, the learning curve remains real. The Nix language, used to write configuration files, is not like Bash scripting or YAML, it's a functional, declarative language with its own syntax and semantics. New users often find it unfamiliar. Debugging configuration errors can be confusing at first. When something fails to build, error messages may reference deep dependency graphs. This is not a beginner-focused distribution in the same way Ubuntu or Linux Mint aim to be. You can install NixOS and use it casually, but the moment you want to modify system-level behavior, you're interacting with the Nix language. So the question becomes, are you willing to learn it? If you're a developer comfortable with programming concepts, especially functional programming ideas, Nix can feel logical and powerful. If you're a casual user who just wants a stable desktop with minimal configuration, the abstraction might feel unnecessary. There's also the concept of Nix flakes, which have become more prominent in recent years. Flakes provide a more standardized way to define and share Nix-based configurations and packages. They improve reproducibility and composability, but add another layer of complexity. For power users, flakes are transformative. For beginners, they're another concept to understand. Performance-wise, NixOS is comparable to other Linux distributions. The runtime experience is not inherently slower, but builds can take time, especially when compiling packages from source. Binary caches help significantly, but the first setup can be heavier than on traditional systems. Disk usage is another consideration, because Nix keeps multiple generations and stores packages with unique hashes. Disk usage can grow. You need to occasionally run garbage collection to remove unused generations. It's not difficult, but it's another maintenance concept to learn. Now let's talk about practicality for daily use. For web browsing, media consumption, coding, document editing, and general productivity, NixOS works well. Desktop environments are polished. Drivers for modern hardware are generally supported. NVIDIA GPUs require configuration tweaks, but documentation exists. Gaming works, but it may require more manual configuration compared to something like Ubuntu with Steam pre-installed. If you enjoy understanding your system deeply, this is a feature, not a bug. If you want plug-and-play simplicity, it can feel like friction. One of the most powerful aspects of NixOS in 2026 is how it bridges local development and production environments. If you're building software that will eventually run in a cloud server, you can define development shells using Nix that exactly match your deployment environment. No more "it works on my machine" problems. Your machine becomes a reproducible artifact. This is why many developers consider NixOS not just a distribution, but a paradigm shift. But let's not ignore the downsides. Documentation, while extensive, can sometimes assume prior knowledge. Community forums are helpful, but often technically dense. If you're troubleshooting a niche issue, solutions may involve understanding how packages are defined in Nix expressions. And because NixOS does things differently, some third-party tutorials written for generic Linux may not apply directly. Configuration files may live in unexpected places. Standard assumptions about file paths may not hold, so is it beginner-friendly? In 2026, it's more beginner-friendly than ever before. The installer is cleaner, graphical environments work out of the box. But philosophically, NixOS expects engagement. It expects you to think about your system declaratively. It expects you to treat configuration as code. If you want to learn deeply how your system works, NixOS is an incredible teacher. If you want minimal mental overhead, there are easier options. Now let's address the bold claim: is NixOS the most powerful Linux distro in 2026? Power can mean different things. If power means raw performance, many distributions are comparable. If power means user base size, NixOS is still smaller than giants like Ubuntu or Fedora. But if power means control, reproducibility, rollback safety, dependency isolation, and alignment with modern infrastructure practices, NixOS is arguably unmatched. It turns your operating system into something versionable, shareable, and predictable. It reduces configuration drift. It makes experimentation safer. It aligns with how large-scale systems are managed in the cloud era. For developers, DevOps engineers, researchers, and power users, this is transformative. For casual users, it might be unnecessary complexity. The beauty of Linux is choice. You don't have to pick one forever. You can experiment. You can install NixOS in a virtual machine. You can try it on spare hardware. You can even install the Nix package manager on another distribution to get a taste of the ecosystem. NixOS represents a different philosophy. Instead of treating your computer as something you manually tweak over time, it treats it as a defined system state. Instead of fearing updates, it encourages them through safe rollbacks. Instead of patching broken dependencies, it isolates them. In a world increasingly defined by reproducibility, automation, and infrastructure as code, NixOS feels ahead of its time. But ahead of its time doesn't always mean right for everyone. If you value stability, safety, and control, and you're willing to invest time learning a new paradigm, NixOS might be the most powerful desktop experience you've ever had. If you want simplicity above all else, you may find its elegance hidden beneath complexity. So is NixOS the most powerful Linux distro in 2026? For the right user, absolutely. For everyone else, it might be a fascinating experiment rather than a daily driver. And that's the honest truth.